Hey guys, welcome back to my YouTube channel. So once again, we are building an image recognition application using computer vision, and we are building an app that will help us recognize coins and help us count them, and the coins we're dealing with is pounds. So we've already gathered our data by taking pictures of coins of different denominations, and then we uploaded them to Google Cloud. We've been able to draw bounding boxes around these coins and label them, so we have bounding boxes on all our images. Then we went ahead to prepare the parameters we need for training our model, and we were able to also start training the model. If you want to learn more about that, please check the last video, which I'm going to link up there. For now, we are going to move on to the model evaluation, and this is where we are going to see how well our model has performed in identifying these coins. So stay tuned. If you also check the Vertex AI sidebar, you'll find the training tab. You'll also find the model registry. The training tab is where the models that are being trained are kept, while the model registry is where all the successfully trained models will be kept. So let's check the training. Select the region, Europe West 4. Where are you? And yeah, so this is the model that we just started training. It's actually going to take more than 2 hours, so you can go do something else with your life and then come back to it. But while this is going on, I'm just going to show you the previously trained model, which I did earlier today, same date as you can see. This one was done some days back. So this is the first model I trained on the data set when the images were just 179 images, and that was okay. I'm just going to open this. So this is your model dashboard. This is what it looks like. You are going to be seeing a lot of things happening here. All the labels has a performance of 85%, and that 85.4% is average precision. When you hover over this question mark, you see what average precision means. When you hover over this, you see what the precision is and then what the recall is. But for each of the labels, you can also get the average precision. So here it says average precision is a measure of how well your model performs across all confidence threshold by calculating the blah 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 blah. You can read that up. And then here, these are two important things I really want us to take note of: this precision and recall. Now, precision here just means what percentage of your positive predictions are actually positive or are correctly positive. Let me explain this with an illustration. We have some coins here. There is 5 pence, there is 1 penny, there's 20 pence, and then there's 2 pence. I'm trying to evaluate the performance of my model on the 5 pence coins. So I said to the model, find me the 5 pence coins. Then the model says these 4 coins are 5 pence, and the evaluation would be that what is the number of true positives. True positive means 5 pence actually. So the true positives divided by true positive plus false positive. So we have 3 of the predictions to be true, and the false positive prediction, which is 1. So that will be 3 divided by 3 plus 1, which is 75%. Now the recall, on the other hand, also recognizes the false negatives. So the precision is trying to focus on the positive predictions to see how good is the prediction, while the recall is trying to focus on the thing we actually wanted to predict, the actual 5 pence. How good was the model in identifying the 5 pence? Was he able to identify all of them or some of them? So the recall will be the true positive, which is still 3, divided by true positive plus false negative. So we have 2 false negatives here, and that is 60%. Now the next model, which looks like it has a better performance, is saying that there are 4 of the 5 pence coins. So the precision will be 4 divided by 4 plus 0, because there is no positive prediction that is wrong. There's no false positive here. So it's going to be 4 divided by 4, which is 100%. The recall, on the other hand, is going to consider this false negative here. So it would be 4 positives divided by 4p, 4 positive I mean, plus the 1 negative that was predicted or that was missed in the prediction. So that will be 4 divided by 5, which is 80%. For model number 3, it correctly gets all our 5 pence coins, and it did not miss anyone, it did not wrongly predict anyone. Now let's take this evaluation for each label. For the 50p label, which has the highest precision, when we scroll down, we say the first thing you see is false negative. So it says there's no item to display. So false negative means that the model is supposed to identify this image or this item as 50p, but it failed to identify it as 50p. Now the false positive means that the model identified this stuff or this image or this item as 50p, but it is not 50p. And I can actually see this is a 20p, but my model identified it as 50. Where is it? So this is 50p, correct? This is wrong. So this is supposed to be 20p, but the model identified this as 50p with a confidence of 59.1%. It also says this is 50p with a confidence of 60%, and I think that's actually 60p, but I didn't label it because it was not full. Now this happened as a result of cropping our images. This particular image has lots of coins on it, so cropping it actually removed some of the images. So you have to be careful when you are doing your image pre-processing. You can also remove images like this if you come across them during your labeling step. Okay, so we go back here. Now for 20p, the average precision is 96.2%, 0.962. This 0.9 and above is actually a good score. When we come down to this 2p, we can see that it's 0.167, which is very, 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 very poor. And like I said earlier, that was because our 2p coins were not much in the data set. So let's just take a look at this. First, your model should have predicted 2p for these images. The model didn't know whether this was 2p or not because it didn't have enough images to train with in the first place. And there's actually no true positive, okay? The 1p also has a low score. The 10p, not too bad, but it can be improved on. So that is it for this particular model. After I added more 2p's and more 1p's, I was able to retrain the model. Let's just go back to the model registry again. Same model, but I retrained it on a new version. So this is version 2, which says I actually did this myself. I'm going to show you how to do this very soon. So it says added more 2p and 1p coins to improve their predictions. Okay, so that's what I did for this version of the same model. So I'm going to click on version 2. Yep, we can see the difference in version 2. Now 2p has actually gone up, because what happened was that I got so focused on getting more 2p images. Now we can see that our 2p performance is better than it was from 0.1 to 0.98. Our 1p has also improved. I think it was 0.6, I think. Now it's 0.88. If you want, you can also add more 1p images to this to get up to 0.9 and above. So let's see the individual performances. False positive, your model incorrectly predicted 2p on these images. Yeah, this is wrong. This is not 2p. Let's see. This is actually 2p, But like I said, because it's not full, I did not label this. And now it's affecting the performance of my model. I should have just discarded this image. Okay, let's go back. True positive. Yeah, this is positive, and it is truly, truly, truly positive. This is 2p. This is 2p. This is 2p. This image is actually one of the images I added recently to improve the performance of this model, and it actually worked. So I have 1p here, 2, this is 5, this is 10, 50. I'm supposed to have 20 here, but I didn't have a 20p coin at this point. So this is 50, this is £1, which is 100p, and then this is £2, 200p. Okay guys, so that is it for model evaluation.